Okay, super important fact to start out chapter 5. As long as velocity is positive, the area under a velocity curve gives distance traveled. So here are 3 examples. These are good examples to start with because we're going to be able to find the area under the curve knowing what we already know about geometry. So, a car moves with a velocity 3/5 t plus 4 miles per minute for time 0 to 5 minutes. How far does the car travel during that time? Well, I've been given velocity. I want to find the area under the velocity curve. So here is the velocity curve. There's time. This is v of t. And I need the area between that curve and the time axis between time equals 0 and time equals 5. Well, all I have to do is recognize that this is a trapezoid. I hope that's all we have to do. So, how do I find the area of a trapezoid? I have, think of this as base 1 plus base 2. I take the average of the bases. So, that's 4 plus 7 over 2. I'm going to multiply it by the width of that trapezoid, which is 5. So 4 plus 7 is 11. 11 over 2 times 5 makes 55 halves. Feel free to simplify, that's fine. Notice the units on time, the units on the 5 are minutes, and the units on the V values are miles per minute, so I'm multiplying miles per minute times minutes. I get 55 halves miles. We have another example now. What if my velocity is the square root of 16 minus t squared centimeters per second for time 0 to 4? So you could make a graph, like a t-chart, and look at this graph. What I'm hoping is that you'll start to recognize that this is the formula for half of a circle. If I had started, that's a circle with center at the origin, radius 4. But it's only the positive half because I only have the positive square root answers. So since I'm only going to look at times from 0 to 4, what I end up is with a quarter circle. So this is the velocity. If I want to find distance traveled, I need the area under the velocity curve between 0 and 4. Ask yourself, what is the area of a quarter circle whose radius is 4? So that's pi times 4 squared. Pi r squared is the area of a circle. We're going to divide by 4 because it's only 1/4 of the circle. So I get 16 pi over 4. 4 pi. And the units again, my units for the time axis are, what are they? Seconds. My units for the velocity axis are centimeters per second. I end up with units of centimeters, so the particle travels 4 pi centimeters. So one last example, I have a car traveling on a straight road for 0 to 24 seconds. The velocity is given by this graph. Which is piecewise and linear. The question is, how far does the car travel during that interval 0 to 24 seconds? Well, here we go. Distance traveled is area under the velocity curve, so I need essentially the area of this shape, which I hope again you'll recognize as a trapezoid. I can compute the area of a trapezoid. That's the average of the bases multiplied by the height. So the base on top is the difference between 4 and 16, that's 12. Across the bottom, that goes from 0 to 24, so that's 24. I'm going to take the average of those two, and I'm going to multiply by the height. The height of that trapezoid is 20. And I get 36 times 10, so 360. Whatever the units were. 360 meters traveled in those 24 seconds.